So I hope so. Looking very clear. Okay. Now, basically, nodal analysis basically application of that one is application of KCL. Okay, that is nodal analysis. According to that one, visibility is clear now. That is application of KCL. Corresponding to that one, first one, mention all branch current. Okay, mention in branch current. After that, node voltage. And third one, reference node or ductum node. Take any reference node or ductum node. Okay, node or ductum node. Take. Okay, so first one we have considered branch current. After that, node voltage. Decide node voltage. After that, one node as a consider as a reference node. Okay, a reference node always with assume 0. Okay, reference node according to that law, say this basically this one is the application of KCL. Simply always consider branch current. After that, node voltage decided. Okay, take node that one V1, V2, V3, whatever, how many node, consider V1, V2, V3, and after that one node take reference node, and after that apply KCL. Basically apply KCL at node, then determine whatever be the value of if you want. Okay, so how can do? Suppose that question like that one. Okay, here, so first of all, current, branch current, here I1, here I2, and here I3. There are 3 branch, so that one is I1, here I2, here I3 current. Okay, we have considered I1, I2, I3. After that, what about how many nodes? At least 3 branch, where 3 branch connected here and here. So that one is V1 and that one is V2. Okay, and after the third point, one node considered as a reference node. So that one is considered as reference node. The reference node means if you take 0 voltages, take 0 voltages. Okay, now after that apply KCL. If you apply KCL, okay, fourth point is apply KCL. So at that node, no any incoming current, all current are outgoing. So here I1, I2, and I3, this is equal to 0. Okay, at that node, if you apply KCL at that node, no any incoming current, all current are outgoing. So incoming current is 0. This is equal to sum of outgoing current. Sum of outgoing current is equal to sum of incoming current. That is called KCL. Okay, so you apply that one, then we got I1 plus I2 plus I3. This is equal to 0. So what about I1? I1 basically here V1 minus that current, that voltage 0. So V 0. Current leave from positive terminal. So that one is, this one is positive or negative? Lot of confusion. Lot of students confused. Sir, we have taken positive or negative. So first of all, we have considered this one V1 connected to here minus, here plus, that is E2. Okay, and that one is R2, and here V2, and here V1. Current leave from going on V1 to V2. Okay, what is the meaning of that one? Basically that one is plus minus V2, here plus minus V1, here minus, here plus. and that is E2, and that is R2. Okay, basically this one represent like that one, and apply KVL in this loop. -2 plus current here I1. Okay, basically the circuit represent like that one. What is the meaning of that one? V1 means with respect to ground, that is V1, and here minus, that is V2. Okay, so first of all, if circuit given like that one, so what about I1? How can we write now I1? So if you consider this one circuit basically represent like that one. So -2 plus, if you apply KVL in this loop, -2 plus which sign? Minus, so minus V1, plus 2 minus plus E2, minus E2, current enter positive and leave negative. Positive plus I1 into R2 plus E2, sorry V2, this is equal to 0. So what about I1? I1 this is equal to, basically we got how much? V1 minus V2, and that one E2 divided by R2. Okay, means if you going on here to here, simply apply V1 minus V2, V1 minus V2. Okay, current leave from positive terminal, so that one positive, divided by how much resistance? Total resistance, that is R2. So clear or not? So how can apply? So first of all, make it. After that, I'll take a screenshot, then I will move. Okay, clear or not? So simply, if you determine I1 means V1 minus V2. First of all, how can right now here simply V1 minus V2, V1 minus V2, and if current leave, if any source connected here, that is voltage source connect, so that one is positive and here negative. Current leave from positive terminal, so positive. So positive sign E2 divided by how much resistance connected in this branch, that is R2, so divided by R2. Clear or not? If anyone faced doubt, then tell me, sir, I faced doubt corresponding to that one. I will explain again. I will explain again. Okay? I will explain again. If anyone faced doubt, tell me first. Otherwise, clear? So this one remove. If leave from negative to no, then that one is negative. Okay? If anyone faced doubt, then I will explain again. Sorry. Remove this one. Remove this one. Remove this one. Clear? And what about I3? If you want to I3 means if you apply that formula, V1 and that one is V2, currently from negative terminal, so minus E1 divided by how many resistance connected in this branch, that is R1, simply R1. Okay, now you apply KCL, sorry, apply here. What about I2? I2 is simply how much? V1 minus V2, no any source connected in between these two terminals, so simply R3. Okay, make it. If you face any doubt, then tell me, sir, I face doubt corresponding to that topic or that line. I will explain again. So clear or not? So now take problem after that. Make it. I will take problems. Okay. If anyone face doubt, then tell me, sir, please explain or okay, then I will take problem. So you can remove. Now take problems. That one is 10 ohm. That is 5 ohm, and here plus minus 200 volt, and here given current, a current source connected here, how much? 5 ampere, and that is 10 ohm, and that one is 10 ohm, and that one is simply a voltage source connected like that one, that is how much? Plus minus 100 volt. Our motto: determine current in all branch, I1 and what about I2, okay, with the help of nodal analysis. If question mention with the help of nodal analysis, so you can apply always nodal analysis, okay, clear? If anyone faced out, then tell me, sir, I please explain, otherwise I will go. Okay. So how can I do it? First of all, if you see very carefully, now how can I do? First of all, simply if you apply nodal analysis, with the help of nodal analysis, if question mention using simple nodal analysis, that you can use always nodal analysis, not other method, okay. So first of all, decide, mention all branch current, here I1, here I2. After that, node voltage, that one is a node voltage, that one node, that one node, at least 3 branch connected at any point, that is called node, okay. So that is V1 and that one is V2, okay, that one is V2, that one is V2, and after that, third point, say one node, take a reference node. So we have taken that one reference node, means 0 voltage, that is 0 voltage, okay. After that, apply KCL at node, here apply KCL at that node. So in incoming current, apply right now here, apply KCL at node V1. If you apply KCL at node V1, then what about V1? Simply, if you apply KCL at that node, incoming current, no any incoming current at that node, all current are outgoing current. Here 5 ampere I1 and I2. So written here 5 ampere, this is equal to I1 plus I2. What about I1? I1 is basically, I have already discussed, V1 minus V2, written V1 minus V2. Current leave from negative terminal, so minus 200, divided by how much? 5, plus, now again, what about I2? V1 minus 0, V1 minus 0, current leave from negative terminal, so minus 100, divided by how much? 10, this is equal to 5. So 5, this is equal to V1 minus 2, sorry, that is 2 times V1 minus V2 plus V1, okay. If you take LCM, basically multiply by 2, so 2V1 minus 2V2 minus 400 plus V1 minus 100, divided by how much? 10. So that is 50, this is equal to 3V1. And what about V2? V2 basically 0. We have taken a reference node, that's why 0. Put here V2 0. So 400 minus 100, that is how much? 500. So 3V1, this is equal to 500 plus 50. So 550. So what about V1? That is 550 divided by 3 volt. Okay. So V1 basically how much? 5 divided by 3 volt. That is node voltage V1 is how much? That is 5 by 3 volt. Okay. If anyone faced out, then tell me, sir, I faced out corresponding to that topic. I will explain again. I will explain again. Okay. Now, after that, our motto determine I1, I2. So, first of all, you can do. So, what about I1? I1 is basically, what about I1? I1 is V1 minus 0. V1 minus 0, that is this one. V1 is how much? 550 divided by 3. So basically, what about that value? Using calci. Okay. So it is 550 divided by how much? 3. That is 183. 183.33. Okay. So first of all, if this one remove, then how much? 183.33 minus 200 divided by 5 minus 200 divided by 5. So finally we got how much? 3.33. 3 point minus 3.33 ampere. That is I1. And what about I2? I2 is written as V1 is how much? 183.33 minus, currently from negative terminal, so minus 100 divided by how much? That is 10. So 83, so 8.33 ampere is the right answer. Make it. Okay. So first of all, make it. I will take another problem. If you face any doubt corresponding to that one, then tell me. I will explain. I will explain again. Okay. I will explain again. If anyone faced doubt corresponding to that one, then I will explain again. Okay. I will explain again. I will explain again. Okay. I hope so. Now, next problem is that is 2 kilo ohm, that one is 2 kilo ohm, and that one is 1 kilo ohm, and that one is 3 kilo ohm. Okay. And that one is how much? 24 milliampere. Okay. And that one is 6 kilo ohm. That one is 6 kilo ohm. 6 kilo ohm. Our motto determine that current. That current is name is Ix. Okay. And here basically that one is shit. This one, sorry, shit. This one is how much? 6 kilo ohm. Okay, that one is connect here, and after that, that one is connect here. Okay, basically that one is resistance is also 6 kilo ohm. Okay, up, and that one is how much? 12 kilo ohm. That is 12 kilo ohm. Okay, and that one is 6 kilo ohm. and our motor determine Ix. Our motor determine Ix. Our motor determine that current and whatever resistance, that is 6 kilo ohm. So our motor determine Ix. So first of all, if everyone try, okay, then I can do. First of all, everyone try, then I will do. Okay. Everyone can try. Okay. After that, I can do. Okay. Try. If you try, if anyone faced doubt, then tell me, sir, I faced doubt corresponding to that one. Then I will explain again. Okay. Now, I hope so. How can do? First of all, if you see very carefully, so make it here. After that, one thing. How can do? Now, what about branch current? First of all, decide branch current. If you see that volt, that one and that one are same voltage, that one and that one are same voltage, and this one, these are series, sorry, parallel. So combination of these two, first of all, and these two are in series, and these two are also series. Basically, these two are in series, and these two also series, and that these two are parallel. So first of all, minimize that circuit. Okay. So, and that one is how much? 24 milliampere. Okay. First of all, written that one 24 milliampere, and 2 and 6, that is 8 ohm. That is how much? 8 ohm, 8 kilo ohm, and 1 plus 3, that is 4 kilo ohm. That is 4 kilo ohm. Okay. And 6 and 12 both are parallel. So 18, 6, 3, yeah, that is 4 kilo ohm. So that one is 4 kilo. Oh, sorry. That is basically mistake here. 6 and combination of these two, how much? 4 kilo ohm. And that one is connected here. Okay. After that, this one I have considered here I1 current and here I2 current. Sorry, that current is known as Ix. Okay, so branch current, this one is branch current. Our motto, suppose that is V1, and this one is take ductum node. Okay, now after that, apply KCL. Apply KCL at a node. Which node? V1. So I1 plus I2, outgoing current I1 plus Ix, this will equal to 24 milliampere. So what about I1? I1 is basically V1 minus 0 divided by 4 kilo ohm. And what about Ix? Ix is basically V1 minus 0 divided by how much? 8 and 4 are in series. So that is 12. This will equal to 24. Okay. Take LCM. Here, that is 3V1 plus V1. This will equal to 24 into 12. So 4V1, this will equal to 24 into 12. So what about V1? V1 is 72 volt. And what about Ix? So finally Ix is written how much? Ix is written how much? V1 minus 0 divided by 8 plus 4, 12. 72 divided by 12. That is 6 milliampere is the right answer. Make it. If anyone faced doubt, then tell me, I will explain again. If anyone faced doubt corresponding to that one, then I will explain again. Okay, make it. Ix is 6 milliampere. Okay. If anyone faced doubt, then tell me that I faced doubt corresponding to that topic or that step, then I will explain again. Okay. I hope so. Okay. So now next problem is I will take another problem. That one is 12 kilo ohm. Okay. A current source, how much? 6 milliampere. Okay. And that one is how much? 10 kilo ohm. And that one is 6 kilo ohm. And here that is 3 kilo ohm. Our motto determine I naught, and here that is 12 kilo ohm. Okay. Our motto determine what about I naught with the help of nodal analysis. Our motto determine I naught with the help of okay, with the help of nodal analysis. So first of all, everyone try. Thank you, well done. Now everyone try, then I will resolve that question. Very simple. What I am saying, nodal analysis means first step decide branch current. Okay, all branch current mention. Okay, so first of all, mention all branch current. This branch current and this branch current are already given. So that what about that branch current? Suppose that I1, whatever be the direction, as per your convenience. Okay, here I1, here I2, and here I3. Simple. So all branch current are decided I1, I2, I0, I3. After that, decide node voltage. That one is V1, that one is V2, and that one is V3, and that is V3. This is V3, and that is V4. Okay. After that, node voltage. If this one is one node voltage, take ductum node. Ductum node means reference node. If this one is 0 voltage, that means also 0. Why? Because of these two are that node and that node. No any source connected between resistance or any source connected between these two. Oh, these two nodes. Okay. So that's why if this one is V3, then also same voltage. That 2 points are same voltage. That's why we connect. We are written if there is 0, that is also 0. Okay. So simply apply KCL at that node, and after that apply KCL at that node. Clear or not? So one by one, apply KCL at V1 and after that apply KCL at V2. Now apply KCL at node V1 and after that V2. Okay. What about incoming current at that node? That is 6 milliampere. Outgoing current I1 plus I3. What about I1? I1 is written V1 minus 0. V1 minus 0. Total resistance in this branch, that is how much? 12. What about I3? I3 is written as V1 minus V2 divided by how much? 10 kilo ohm. So 10, 6. Okay. Clear or not? If anyone faced out, then tell me, I will explain again. Now, so first of all, take LCM. Here 6, this will equal to 10 V1 plus 12 V1 minus 12 V2 divided by how much? 120. Okay. After that, 10 plus 12, that is 22. 22 V1 minus 12 V2. This will equal to 6 into 120. If divide by 2 in both sides, then we got 11 V1 minus 6 V2. This will equal to 3 into 12. 360, equation number 1. Clear? After that, apply KCL at that node. Okay? Everyone apply KCL at that node. I3, this will equal to, I3 is written as incoming current I3, outgoing current I0 plus I2. What about I3? That is V1 minus V2 divided by how much? 10 kilo ohm. So 10. I0 is written as V2 minus 0 divided by how much? 6. And what about I2? I2 is written as V2 minus 0 divided by how much? That is 3 kilo ohm. Clear or not? Clear or not? Now, after that, if you see very carefully, if take LCM, okay, then we got how much? That is V2 plus 6 in now V2 plus 2 times V2, that is 3 times V2 divided by 6, that is you can say that V by 2, V2 by 2, basically this one is V2 by 2. If you're solving these two, then we got V2 by 2. Okay, V2 by 2, this is equal to V1 minus V2 by 10. Now after that, V1 minus V2, this is equal to how much? 10 divided by 2, that is 5V2. 5V2. So 6V2, this will equal to V1. 6V2, this will equal to V1. So V1 replace, basically our motto, if you determine, if that value put here, then we got how much? 11 into 6, that is 66 V2 minus 6 V2. This will equal to how much? That is, 360. 360 and 60 V2. This will equal to 360. Then what about V2? That is 0, 6 volt. That is 6 volt. So what about V1? V1 basically is 36 volt. So finally V1 is 36 volt. Now after that, our motto determine I0. I0 is, what about I0? V2 by 6. I0 is basically V2 by 6. You put here V2 is 6 by 6. That is how much? 1 milliampere is the right answer. Make it. If anyone phased out, then tell me. I will explain again. I will explain again. Okay? I will explain again. I will explain again. Okay? Make it. I hope so. Visibility is clear. Okay? So first of all, make it. If anyone phased out, then tell me. Sir, I phased out at that stage. Then I will explain. If anyone phased out at that, then tell me. Comment it. I will discuss again. Okay? If anyone phased out, then tell, sir, I phased out. Okay? Then I will explain again. Because your feedback is very important for me, for my side. Your valuable feedback is very important for me. Then I will decide which type of question. This question is easy or tough. If easy, then tell me, sir, it is easy. So take difficult problem. If you face difficult question, then tell me, sir, take some easy problem. Then I will, after that, take difficult problem. Okay? Explanation is good, then tell me your explanation is good. Okay? I hope so. If anyone faced doubt, then tell me. Okay? Otherwise, I will take another problem. Otherwise, I will take another problem. Okay? So now next problem is, now next I have take next problem. This one is 3 kilo ohm. That one is 3 kilo ohm. A current source represent like that one. Okay? And that current source is 6 milliampere. And that one is 2 kilo ohm. And here that is how much? 4 milliampere. 4 milliampere. It connected, and that one is 2 kilo ohm, and another resistance connected here, that one is 2 kilo ohm. Okay, our motto determine that voltage V1. Okay, so what about V1? So what about V1? Okay, so what about V1? So first of all, everyone can do, then I will explain. First of all, try everyone, and after that I will do. If anyone phased out, then tell me. So I phased out corresponding to that step. Then I will explain again. Okay. Now, corresponding to question here, our motto determine V1. With the help of that question, you can do with the help of nodal analysis. If question say node with using nodal analysis, then you can apply simple nodal analysis. Not you can use other method. Okay. So first of all, how can try? I know that if you apply nodal analysis means for what about first step? First step say decide branch current. Okay. What about branch current? Okay. So branch current is here I1. First of all, decide branch current. Okay. What about branch current? Here I1, and suppose that here I2, here I3, and here I4. After that, second step, node voltage decide V1, here V2, and here V3, and here V4. Next step, reference, take a reference node. If this one is take reference node, that is zero voltage, then it also zero voltage. Why? Because of no any source connected between in these two terminals. No source voltage, no any resistance. So that point voltage, that point voltage are same. It means if you this one is zero, that is also zero. Okay. It means you can remove this one, remove, simply written that one is 0 volt and that one is 0 volt. Is clear or not? After that, apply KCL at that node and that node. Now apply KCL at node V1 and V2. V1 and V2. I1 plus I2 plus 6 ampere. I1 plus I2 plus 6, this is equal to 0. Okay. Outgoing current I1, 6 and I2. What about incoming current? No incoming current. If you apply KCL, apply. What about KCL? KCL say sum of incoming this is equal to sum of outgoing current at any node. So outgoing current I1, I2 and 6. This is equal to no any incoming current, so 0. Clear? So what about I1? I1 is V1 minus 0. V1 minus 0 divided by how much? That is 3 kilo ohm. Basically, if you take here Vx, so Vx also Vx basically V1. If anyone phased out, why Vx written V1? Suppose that here Vx by mistake, basically here V1 already given, that's why. Okay, so we have to consider that is Vx. Silly mistake here. So that if this one is Vx, then Vx is equal to V1. If anyone phased out, why written Vx is equal to V1? Then, so first of all, make here that is plus minus V1 and here Vx, and that one is 0 voltage. So 0 voltage. Basically, this one represent plus minus V1, and here that is Vx, that is plus minus 0 volt. If you apply KCL, if you apply KVL, then minus Vx plus 2 minus V1 is equal to 0. So Vx is equal to V1. So clear or not? Why Vx is written V1? So basically this voltage is V1. So that's why written V1 minus 0 divided by 3 kilo ohm. Plus what about I2? I2 is written V1 minus V2 by 2. Okay. So you can remove here that one and that one. Okay. Now that is how much? V1 minus V2. V1 minus V2 divided by 2 plus 6, this is equal to 0. Now take LCM, then 2V1 plus 3V1 minus 3V2 plus 36, this is equal to 0. So 2 plus 3, that is 5V1 minus 3V2 plus 36, this is equal to 0. Okay. So 3V2 minus 5V1 is equal to 36, equation number 1. If anyone phased out, then tell me, sir, I phased out at that point, at that step, then I will explain again. If anyone phased out corresponding to any step, then tell me. Comment it. I will explain again. Okay, so 3v2 minus 5v1, this will equal to 36. That is question number 1. If apply KCL at that node, okay, incoming current I2, outgoing current 4 milliampere plus I3 plus I4. Okay, so first of all, make it after that. This one, this one, this one, this one, I will remove. Okay, I2 is written. What about I2? V1 minus V2. Sorry, V1 minus V2 divided by how much? 2. This will equal to 4. I3 is written as V2 minus 0 divided by how much? 2 kilo ohm. And what about I4? I4 is written as V2 minus 0 divided by 2. Okay, simply. That one is 4 plus V2 and that one is V1 minus V2 divided by 2. So V1 minus V2 basically 8 plus 2V2. Okay, V1 plus 3 times V2, this is equal to 8, equation number 2. And that one is minus 5V1 plus 3V2, this is equal to 36, equation number 1. So if this one remove, now look, plus minus minus, that is 6V1, this is equal to how much? 8 minus 36, 36 minus 36 plus 8, that is how much? Minus 28. So V1 is how much? 28 by 6, that is 14 divided by 3, minus 14 by 3. Now, if that value put, basically our motor determine that one, V1. So finally V1 is how much? Recheck again. If multiply by 2, that is 4 into V2, 4 plus V2. And if multiply by 2, then we got V1 minus 0, 8 plus 2 times V2. Okay. After that, one mistake. Sorry, this one silly mistake here. Here minus. Okay. So it means silly mistake sometimes. If equation number 1 and 2 are adding, then we got how much? Minus 4V1. This will be equal to 44. So what about V1? 44 minus 4. It means minus 11 volt is the right answer. Make it. If anyone phased out, then tell me. I will explain again. If anyone phased out, tell me. I will explain again. Okay. So I hope so. Your all doubt are clear. Today's session. Okay. If anyone phased out, then tell me. I will explain again. Okay. Tomorrow I will take another prop. Tomorrow I will take nodal analysis based problem at same time. Okay, 9 to 10. So if anyone phased out, then tell me. Tell in comment. I phased out, or if you. Okay. Any query corresponding to circuit, then 9 plus 91 9041 398 104. Call me or WhatsApp me on that number. Okay. Thank you very much for joining for my class.